Let's discuss this topic, that is a solution of linear equations. That we are learning first homogeneous linear equations. Actually, this is the applications of matrices, where we are using matrix topic, whatever the concepts we are using means to find the solution for linear equations. Already we know how to find a solution for some equations. If two equations are given, how to find solution we know. But whatever the concept, matrices concept was there, that's we are using here to find a solution of a linear equation very easily by using matrix concept we will find. How to find? What are the linear equations? How we are going with? We'll see. See here in our syllabus we are having a linear equation, that too homogeneous and non-homogeneous also. First we will see non-homogeneous. That too here we are taking equations, linear equations containing three unknowns. Three unknowns. Here I am writing that equation. To say three unknowns we required three equations. That is I am writing here a1x plus a2x plus a3z equal to d1. Next b1x plus b2y plus b3z equal to d2. c1x plus c2y plus c3z equal to d3. Let's consider three equations having three unknowns and three equations. Those are a1x plus b1y plus c1z equal to d1, a2x plus b2y plus c2z equal to d2. Next a3x plus b3y plus c3z equal to d3. These are the three equations. I am taking equation number 1, equation number 2 and equation number 3. It's having three unknowns, that is x, y, z, and with some constant coefficients. To decide to say three unknowns we require minimum three equations. More than three also we can get, but to say three unknowns, minimum three equations are required. That's why we taken three equations. By using that, in these three equations we are having three unknowns. Here these are the linear equations. We have to find the solution for these three linear equations. Before that, I am converting these three equations into matrix form. That is converting into matrix form. That's I am writing here, that is a1 b1 c1 a2 b2 c2 a3 b3 c3, and here x y z equal to d1 d2 d3. See, we are naming these equations, the matrices. This is what coefficient matrix. This is going to be variable matrix. This is going to be constant matrix. These are the three matrices. By applying whatever the properties in matrices, if you do here, this is what 3 by 3 matrix, this is what 3 by 1 matrix, this is what 3 by 1. To multiply two matrices, must and should it satisfies what condition? What is that? Number of columns of a first matrix should be equals to number of rows of a second matrix. Here number of columns here 3, number of rows are 3, both are going to be equal. That's why matrix multiplication is possible. The resultant matrix is number of rows of a first matrix by number of columns of a second matrix. That's why 3 by 1. Simply if you multiply these two matrices, you will get these three equations. If you want, you can check a1x plus b1y plus c1z, first element, that is going to be d1. And resultant matrix 3 by 1 matrix, the resultant values, that is a2x plus b2y plus c2z, that is second row first column element, equal to here second row first column element d2. Simply whatever, if you multiply these two matrices, whatever you are getting values, that by using that we can say this about system. We are naming this as ax equals to b. This is a, this is x, this is b. A is coefficient matrix, b, x is a variable matrix, b is a constant matrix. Always the variable matrix is nothing but x, x is nothing but what? These three values, x, y, z. X, y, z. Here to answer the questions here in ECET you are going to get some type of questions. Before that we have to know two values, that is a consistent system. Another one is a inconsistent system. See, three equations are there. These three equations are going to be solution. What is that solution? Saying unknowns, that is x, y, z. Three values chapali. Total the three values are going to be x, y, z. In each and every equation that values are going to be satisfied. Compulsory, must and should. If it is solution means the whatever just you are finding the values that will satisfy these three equations. A oka equation is satisfy cheyakuna appudu rasina x, y, z values ni solution anam. Compulsory x value, y value, z value ఏదైతే త్రీ వాల్యూస్ ఉన్నాయో త్రీ వాల్యూస్ ఈ ఎనీ ఈక్వేషన్లో సబ్స్టిట్యూట్ చేసినా కూడా ఈక్వేషన్ అనేది సాటిస్ఫై చేయాలి, అప్పుడే సొల్యూషన్ అవుతుంది. అట్లా కన్సిస్టెంట్ అంటే వీఆర్ టాకింగ్ అబౌట్ దిస్ టోటల్ ఈక్వేషన్స్. This clubbingly we are saying as a system, that we are saying consistent equations, we can say consistent systems. Consistent system is nothing but it has a solution. That having solution, only one solution, it may be unique solution or a infinity solutions also. సొల్యూషన్ ఉంటే అయిపోయా, ఒకటే సొల్యూషన్ ఉన్నా సరే ఎన్ నెంబర్ ఆఫ్ సొల్యూషన్స్ ఉన్నా సరే సొల్యూషన్ ఉంటే దాన్ని ఏమనాలి? కన్సిస్టెంట్ సిస్టమ్ అనాలి. ఇఫ్ ఇట్ హ్యాజ్ అ నో సొల్యూషన్ అంటే సొల్యూషన్ అనేది రాలా, ఎగ్జిస్ట్ కాలే, అప్పుడు ఏమంటున్నాం అంటే ఇన్కన్సిస్టెంట్ సిస్టమ్ అంటారు. ఫర్ హోమోజీనియస్, నాన్ హోమోజీనియస్ సిస్టమ్, ఇఫ్ దిస్ three values constant matrix is equals to null matrix, d1, d2, d3 are going to be zeros, then that is said to be homogeneous. We will talk about later. But non-homogeneous system. In your syllabus, to say answers for this, we are going to have three methods. One is inverse matrix method, another one is Cramer's rule, another one is Gauss-Jordan method. But we are not discussing these three methods, but I will given a description about what is inverse, what is Cramer's rule, what is Gauss-Jordan method, we will say. But before that, before to discuss that values, that methods, we have to know some method. Here it system is having solution or not, by seeing these three matrices we can say that. About that we will discuss first, then after we will discuss methods of finding solutions. What is going to be, I will give brief discussion, but we won't do the problems by using that methods. But here see, he will ask the questions, is this system is consistent system or not? He will give three equations, the given equations are consistent equations or inconsistent equations he will ask. To say consistent, inconsistent means you have to find the solution by using whatever just before I said. After finding the solution, then only you can say is consistent or inconsistent. Solution వస్తే consistent అంటాం, solution రాకపోతే inconsistent. మరి ఉచ్చారాధ చేయాలంటే it will take more time to find by using that methods that solution. That's why by seeing this matrix with simple finding determinant, we can say given system is inconsistent or consistent. See how means here first one I am saying that is if determinant of A, if determinant of A is nothing but what? Coefficient matrix. If determinant of A not equal to 0, and whatever, if you find a determinant for A, if you are getting a not equal to 0 means any number, then given equations are consistent system, that is it has a solution. The solution is a unique solution. Only one solution. Either we can say, if you can say this is it is not equal to 0, then that solution, always the solution is going to be unique solution. Only one solution. If determinant not equal to 0 వచ్చిందంటే, whatever this A is there, if you are getting determinant not equal to 0, then system is a consistent system, we can say, and it's having a solution. That solution always is going to be unique solution. And for suppose one more, if determinant of A not equal to determinant of A equal to 0, determinant of A equal to 0, then system is a inconsistent system. It has a what? Indirectly inconsistent means what? No solution. No solution. But we can say one more also. If determinant equal to 0, more possibility you didn't have solution or you won't get the solution, and also you can get a infinity number of solutions. Infinity number of solutions. You may get no solution or infinity number of solutions. He will give 3 equations, he will ask it has unique solution, no solution, 3 solution, none. Means if you find determinant, if you are getting determinant not equal to 0, it's have unique solution. If determinant equal to 0, no solution or infinity number of solution. If you are getting these both options, then we'll take how to do. Okay, right? Always we are saying here see, by seeing the equations without indirectly how to convert the matrix, then only it's possible to write A or X or B. Means by writing A, we can say given system indirectly by finding determinant for this A, given system is consistent or not, we can see, and also it's have solution or not, we can see, and it's also that solution is unique or no solution also, we can say. Let's see some methods. Here, how to find here indirectly, already we are saying 3 methods. We will talk about these 3 methods. We'll talk about these 3 methods for non-homogeneous system. Okay,